Hello everyone, my name is KabirKhanuja. Why does this sound like a YouTube video? But anyways, hello everyone, my name is KabirKhanuja and I'm an engineering student currently pursuing computer science, and here's my presentation about something that is visually appealing, visually mesmerizing, visually beautiful, and it's just very visual. Okay. But let's get it straight. What is Liquid Galaxy famous for? The screens? Yes. Google Earth being displayed in a mesmerizing way? For sure. The interactivity and tools we get through these resources? Of course. But what is that one thing that makes Liquid Galaxy even more special? Which is just not visually appealing, but it also helps mark things in a way where storytelling resonates. I'm just explaining the title in a very fancy way, but yes, you are right. I'm talking about KMLs. So that's my presentation for today, how Google Earth loads KML in Liquid Galaxy. Because I used to always wonder that KML is just not a PNG or a JPG that you'd copy in a Google Doc and then you'll have it ready and it'll look good. And even if it did, aren't those just limited to two-dimensional figures, only the X and the Y axis? Whereas what makes Google Earth interesting is that we see things in 3 dimensions. And if we see them, then how do they get processed in 3 dimensions or into the system, let alone, and how Google Earth loads KML in Liquid Galaxy? So that's something to figure out. But as always, we start understanding the cornerstone of it. KML. What is KML? And I'm sure it has something to do with that particular figure with its, head cut open, brain coming out and all those thingy. I'm sure it has to do something with that. But okay. So KML basically is keyhole markup language. And the easiest way to understand or think about it is that if Google Earth is the engine, then KML is the instruction manual telling it what to display and what not to display. It's basically an XML based file format, which just means that it uses those structure tags like we have in HTML to describe geographic information. Why geographic? You'll get to know about that yourself. So instead of designing those web pages in HTML, we are describing things on the globe, like location, shapes, camera positions, and even 3D objects for that matter, because again, it is something to do with the dimensions, right? So in the image, you can see there are those 4 colored polygons, right? They basically are KMLs. Now they have been drawn, but they have been processed programmatically, if that makes sense. So for example, if I want to place a KML on Earth, what all can I do? I can use a place mark in KML. I'll explain what place mark is. But yeah, I'd use a place mark in KML. If I want to highlight an area, I can draw a polygon. If I want to show a 3D model, I can link a DAE file. I'll talk about this further in the video. And if I want the camera to move automatically around the locations, I will use a tour, or I will create a tour, right? So in a way, KML is what turns Google Earth from just a map viewer that you'd find in your mobile from going to, your home to McDonald's, I don't know where, into a storytelling platform. And this is exactly why KML is so important in Liquid Galaxy, because everything we send to the rig eventually becomes a KML instruction to the Google Earth that it understands. Though you don't know what or how does KML look in the backend. Okay, so this is how KML looks in the backend. This is an internal structure of KML file used to render the pyramid in the Google Earth. That was for one of the tasks in Liquid Galaxy that I made. So this is the KML file for that. So let's start with the top of it. Okay, this is the top part of this file. It's the header, or we can say it's the XML declaration, right? You can see the version there. So it simply tells the parser that the file is written in XML format and it uses UTF-8 encoding, right? You can think of this again as, an identifier to the parser, right? that it's going to be a KML file. And then it helps Google Earth understand how to read the documents correctly, because there's a way, there's a coherent way in which you process things, right? Next, we have a KML root element, XMLNS, that takes the right version from KML, or it lets the Google Earth know which KML version we are using. GIS is basically geographical information system, right, where it has given it KML/2.2. That's the version, right? So that's how Google Earth knows what version of KML you're using, right? Now there are those document tags that are the main tags where the whole content goes. The document tag acts like a container or a folder that holds all the visualization elements like styles, placement, marks, model, everything. And then we also have the name tag, where you can write the name of the KML. So it's going to be helpful when you have that KML placed on Google Earth. When you hover on the mouse on that KML, currently it maybe by default it gives that placement model kind of a thingy by design. But if it wasn't for that, and if you were to specify the name explicitly here in those name tags, then it's gonna tell you that it's a pyramid, right? Okay, so let's now understand, let's now move on to the styling section of the code. Okay, so you'll notice multiple style blocks defined here, right? There's one more here. So I just broke down the code. There are multiple style blocks here. Okay, so okay, I'll just name them. There are base styles. Okay, so there was base style, and there was phase 1 style, phase 2 style, phase 3 style, and all those. Okay, so these styles control how the surface of the pyramid would look, because it depends on the shape. Currently I've taken pyramid, hence they have those many faces to it, right? Okay, so inside each style, let's get back to this. Inside each style, we use a polystate tag, which defines how polygon surfaces are rendered, right? Then there's the outline tag that determines whether the edges of the polygons are drawn or no. If you increase the thickness of the outline, it'll look a little cartoonish, but that's how it works, right? Then there's the color tag. Okay, that determines the color of the polygon, as we had seen different colors in the KML in the first screen, right? But KML uses a different kind of, you'll say, not render, but a format to render this, right? You won't get FF0033CC in HTML. Those generally are in RGB. So if you want red or black, you'll just go with FFFF or 00000 to obtain those. But here it goes in an alphabetical order. It goes from AA, BB, GG, RR, right? So RGB they are considering, and then they are considering AA, where AA stands for opacity. BB, GG, and RR are basically blue, green, and red. So the value FF0033CC, that means that it's fully opaque with a specific mix of red, green, and blue values, right? And then this allows Google Earth to render colored surface properly in 3D space. Now, the real reason that we define multiple styles is to color different faces of pyramid, right? So wait, I'll just get back to this. I'll come on to this, but okay. The real reason is because it should know which side of pyramid should have what kind of a color and how many sides does that pyramid have. Okay, so this improves the depth perception and makes the 3D model visually clear, and then it gets rendered on the globe. And instead of repeating color definitions for every face, we have, for this example, we have just defined different colors for different face, so you can identify the pyramid in one glance, right? It is basically similar to how CSS works in websites, right? The HTML websites that you create. So it's kind of same. So overall, this section of the KML file is responsible for defining the document structure, declaring rendering rules, and specifying polygon colors and outlines. So that's how a polygon is rendered, right? And once all of these styles are defined, the Google Earth then can apply the model's faces to render the colored 3D pyramid in the liquid galaxy. Then that's the next step. But the first step is to let Google Earth know that how it will look. Okay. So now here we are looking at certain coordinates, right? We're looking at the part of KML that actually defines the shape of the pyramid's face using the coordinates. Okay, so inside the polygon tag, you define this linear ring. Now what linear ring does is it's basically a closed loop of points that forms a polygon. Polygon is not open, right? It ends somewhere, it closes somewhere. If I again consider this famous cube, it ends somewhere, right? So Google Earth is responsible for connecting these points in order to draw the surface, and hence you have to have the linear ring. Okay, so inside that we have those coordinates. Now generally coordinates need to be 3. I'll explain what it is, but okay. And this is a particular structure of coordinates, right? So there's 73.8555, 18.5198 and 0, right? So for these three there's 0 and okay, so the format is longitude, latitude and altitude. Generally I guess it's latitude, longitude, but for the KMLs we go from longitude, latitude and altitude, right? Okay, so you'll notice that these points that are listed, these points basically for the pyramid, they define the corners or the edges of the polygon, right? And then Google Earth connects them sequentially to form a triangular face of pyramid. So also the first coordinate that you see and the last coordinate that you see, they're the same. Why? Because it ends somewhere, right? It joins together, right? And that is required for the polygons in KML. Now, since this pyramid is a 3D object, you will see this altitude mode that is relative to the ground. Now, this tells Google Earth that altitude value should be measured relative to the terrain surface. I'll explain this visually further in the slides, but for now, KML provides us with different kinds of functionality and altitude mode is one of them. So when the coordinates, they have a higher altitude value, so the Google Earth lifts that point upward, forming the pyramid peak, because not every surface is gonna be plane and at one level, right? So, answering the question that why is there 100 in one of those coordinates in altitude, because that's how the pyramid would be formed, right? So everything would be in the base, and there would be one corner that would be having the height, right? So hence there's that 100 is the altitude for that particular pyramid. So basically, in simple terms, that these coordinates or this coordinate block defines where the pyramid exists on the earth and how its faces are shaped in 3D space. The styles we defined earlier, they control the appearance, and these coordinates control the geometry of the whole figure. Okay, and together they create a nice appealing 3D pyramid for this particular presentation. But let's see what these pieces all together in a concoction form. Okay, this is what they form. This is the pyramid that we made because we had different colors and I wanted it really big and large. This is Pune, by the way, this Shaniwar Wada. And yeah, so basically the coordinates that I was talking about, these were the coordinates for this location, right? If you change the coordinates, then this is gonna hover on to some other location, maybe Antarctica or anywhere in the midst of desert. But yes, so these are the faces. It's completely 3D and that's how it renders. I could have changed the color. Now, if the color would have been all towards yellow, then it would look authentic to the pyramid. But this is just an example that you can even change the colors. And if it would have been set to this outline would have set to 0, maybe you wouldn't see those white lines, right? So that's the basic use of those outlines. So that's how it renders, right? Now, this is how KML is processed, right? Okay, so I talked about certain functionalities. Functionalities, right? Just like altitude mode, that is relative to the ground. So it's gonna stay on the ground. But now, okay, let's check the example that's the right side. Okay, that's an absolute mode, that whatever happens to the surface, it won't care, it would just place the model for what it is, right? But in the clamp to ground mode, it would actually take the shape of what the altitude and the whole surface has to offer, and then it would take and it would submerge, or it wouldn't submerge, but it would sit along really well, right? But for the absolute mode, it doesn't care. I mean, I'm not gonna bend for you. It's just gonna be literal straight, right? Okay. Again, this is one of the examples. This is for the clamp to sea floor kind of a function, where it then takes the shape of the in the deep of the ocean, it takes the shape of the ocean floor, as opposed to relative to the ground, which is something that we used, which won't take shape of it, but it will stand in accordance to the surface. So those were some different examples of how KML's or the kind of functionalities that KML has to offer and the way they reciprocate to it. So that's how KMLs are processed. Though it's all good and all, but when you know you're just not gonna have your Google Earth running the KML on a single screen, because Liquid Galaxy is famous for multiple screens. So how does a single KML file get triggered across multiple independent PCs? Is there some kind of a neural connection that occurs? I mean, I don't know. That image says a lot about those neural connections. Is it about something like that? So it follows an architecture to be able to come up with the whole pipeline. Okay, in LG, KML files are not sent directly from the controller to the Google Earth app or on the Google Earth software. It would have been very easy if it was for the direct connection, right? The one in the picture that I showed. Instead, the system follows a tunnel, not a tunnel, but a pipeline, right? Where the Flutter controller app sends an SSH command to the master node, which updates a file called kmls.txt. Inside, there's a root directory. I'll talk about the root directory. Okay. So this file acts like a registry that tells Google Earth which KML files to load, right? And Google Earth on other end continuously watches this particular file, that is kmls.txt, using a refresh mechanism called as network link. So whenever the content of kmls.txt change, Google Earth fetches that referenced KML file from the master and from the master node's web server, and then it renders on different screens, right? And this design keeps controller, the server, and visualizations layers separate, allowing Liquid Galaxy to load visualization dynamically without restarting the Google Earth. If at all there is some new KML or KML occurrence, it won't have to restart the whole system. So that's the reason this pipeline was constructed in the first place. Now, this is the root directory of what I was talking about. So where exactly is kmls.txt stored? Okay, so this is the root directory of the Apache server that's running in the Ubuntu environment, that is /var/ww/html. Okay, you can access file by going to that particular directory where those files are stored, right? I'll show you the example. Okay, this is how they are stored. There are different KML stored, right? And even that file name which I was talking about, this thing, the kmls.txt, that is stored in that particular directory. All right, now kmls.txt basically is like a watch list, that is used by Google Earth in Liquid Galaxy. So Google Earth on master node continuously checks this file to know that which particular KML should I be loading right now. Okay, again, you can take another example. You can think about it as like a playlist, okay, like a playlist file and not actual content. So the first step is that you upload your KML, right? Again, in the same directory, you upload the KML, that would be pyramid.kml, html/pyramid.kml, right? You write that URL. I'll explain. Okay, I'll just go on this next slide. So you have this thingy, http //lg1. Now lg1 says that it's the master node that I've named my master node as lg1, right? The port 81, and there's where I store my pyramid.kml. So the second step is that you after loading the KML inside that particular directory, you then load the URL registry into the kmls.txt, right? So then the step 3 is that Google Earth reads that kml.txt, and then Google Earth fetches that through that URL, that is lg181/pyramid.kml. So again, kmls.txt is like the registry of KML URLs. This link is basically, it's an Apache server that's running, or an Nginx server you can call it, and Google Earth fetches and renders this all. You can also see that echo command. So basically that sends it to the kmls.txt file. When you actually go to that URL, when your server is started, that lg1, as I mentioned, is what I gave the name to my master. So when you go on that URL and hit that on your browser, you can see a complete KML content with all those document and polygon tags. It's basically that XML file that gets printed on the browser. Okay, so now this introduces one of the most important ideas of Liquid Galaxy, that how dynamic content is loaded using network link. Okay, now network link is basically a pointer inside KML file that tells Google Earth to load another KML file from the URL. All right. Instead of embedding everything inside just one large KML, we can keep file in a modular perspective and load them dynamically over the network. Again, it can be like a shortcut on your desktop. I mean, think of it as like a shortcut that is there on your desktop. The shortcut itself is small, but it stores something that is even larger, right? You have those .exes that are stored in your C or D drive, but you can always create the shortcut of the thumbnail, right? So it's something like that. And then Google Earth then reads that, it understands, that go to that LG web server, download that pyramid.kml and render whatever that exists in that KML. Okay, so instead of copying the pyramid geometry into multiple files, we just reference it using a single URL. And this makes updating pretty easy, because if the pyramid changes, the Google Earth has to reload everything, right? So instead of that, it reloads the same link. And this is how Liquid Galaxy supports dynamic visualization, because network link allows content to be refreshed from the server without restarting the complete all those rigs. All right. Okay. Now this was something that we created. I mean, in my opinion, it's one of the finest arts that I've come across till now. I should be bidding this for dollars, millions of dollars, if not billions. Anyways, okay. But what if we could turn this thing into something that has a lot more texture, a lot more thickness, and a lot more detailing to it? What if this was possible? But is this possible with the usage of just KML? Well, no. So absolute cinema. How can we add textures to make it more realistic and like absolute cinema? The answer to that question is 3D models. Now, a KML file does not actually contain 3D objects in itself, right? Instead, I mean, KML is a little lazy, okay, it outsources the work. So what KML does is, it acts like a blueprint or an instruction sheet, like, as I mentioned, for the Google Earth, where the model should appear and how it should be rotated, or how large or small it should be, the size of it. But the actual geometry that of the object is consisted in a folder, or in a file, that is the .dae file, that is a Collada 3D model file. Now an analogy here can be applied, that the KML is the instruction module, right? And the .dae file is the physical object for that manual. In this example, the code snippet that I've posted, right, there's a model tag. Okay, so we define three main things here. First, the location. There's the location tag, which tells Google Earth where to place the model using the longitude, latitude, and altitude as discussed. Second, there's the orientation tag. This controls how the model is rotated using heading, tilts, and roll. And third, the scale. Now this determines how large the model should appear in the world. And finally, the most important part, the link tag, which is there in below in the code. Okay, so that link tag basically tells Google Earth to fetch the 3D models from Liquid Galaxy web server, which is why .dae file must be placed inside. Okay, I'm talking about a golden rule. I'll come to that. Okay, I'll come to that. So when Google Earth loads the KML, it reads this link, it downloads the model file and it renders at the specified location which exists in that file. So again, there's a pipeline for the loading process that the KML loads, the Google Earth reads that model tag, it fetches .dae and then it renders that object, and that's how it loads in the end. Now there's a question, right? These models and all, they are a little complex and it gets a nerve. So are there some mathematics and geometry involved? Of course they do, right? But it's not going to be on a random Sunday when you start drawing KMLs and then deploying it, right? So we discussed something about the orientation tag. So here's the orientation tag, right? It tells that how the model is rotated using headings, tilt, and roll, right? Or even scale for that matter, but more or less it's about the orientation, right? Where you might have to use geometry, but again, those people who wake up on a random Sunday thinking that they want to draw something and have it deployed at the Google Earth won't know mathematics, is what I presume. For them, there are tools that exist like Render, Sketch It Up, where I made myself. No, I didn't make myself. I made the pyramid there. And there's, even Google Earth for that matter, where you just need pen, pencil. So these tools are those drag and drop tools where you have to focus on the creative side of it. So you can focus on the detailing much well, and it's going to be clear as well. Whereas if you were to code the whole thing, you should know the mathematics part, but it's always easier and a piece of cake that you have the software ready, right? But there's one thing that's still missing in order to complete this whole thing. That's the golden rule. Okay, now this golden rule for sure would change the life if grades didn't. Okay, so both the KML and the DAE must be in the same folder or directory to be reachable by the cluster. So it did happen that while loading my KML with the model in the LG rec, I was not able to get the one which I created with the texture. I mean, the pyramid that I showed you earlier was the one that got rendered and it was placed, but the one which had those textures, that didn't load at all. And the sole reason for that was that I wasn't having those two files, the DAE and KML, in the folder. And also you gotta link them. So if these two conditions are satisfied, then you have it. You have your model already and it's rendered properly and it's reachable to the cluster. Okay. So if you couldn't visualize the whole process that I talked about, I'll just have that already in through this diagram. Okay, on the left, you can see the Flutter app, right? It's a controller app, which acts as the remote control for the rig. So when a user triggers an action, like sending a pyramid model, the app doesn't directly talk to Google Earth. Hey, I want to have my KML get on the Earth. No, it doesn't happen that way. Instead, it communicates with the master node using SSH. Now, there are two things happening here. First, using SFTP, the app uploads the required assets like the KML and the 3D model file, that is the .da file, into the Liquid Galaxy web directory, which is /var/www/html. Second, the app then sends an SSH command to update the kmls.txt file. This is basically the registry for the Google Earth, as I mentioned, right? Which watches the whole thing continuously. And now comes the important part, the sync watcher, which is Google Earth's constant monitoring system, right? It watches kmls.txt. Okay. So the pipeline is very, very clear. You have the controller app you have those SSH and SFTP tunnels ready. You have the assets in the folder from where it is taken. It goes on that directory that is /var/www/html. The sync watcher gets it from the kmls.txt, and then it renders, and it is boom, it's there on the Google Earth, right? So this architecture is pretty powerful because it separates the control from file serving and from the rendering part, okay, making Liquid Galaxy a little more modular and easy to automate the whole thing. So to summarize all that we have learned today, Liquid Galaxy loads visualizations through an internal web server, while kmls.txt acts as the orchestration layer, telling Google Earth what to display and what not to. Now, KML files reference assets using URLs instead of the orthodox local paths, and 3D models must exist alongside of KML in the web directory for everything to be rendered smoothly and correctly. So that's about it. I'm sure y'all have sticked around till the end, and I'm sure y'all learned something from today, and it wasn't waste, right? Y'all understood everything in depth, that how KMLs operate, how they get processed, everything that I knew about KMLs, right? Well, anyways, thank you. Thank you so much for listening to this presentation. This was my third presentation. And yeah, have a great day. Cherish every moment. Until next time, thank you guys. Peace. Peace.